Hello and welcome to another session of this series on R programming, a beginner-friendly introduction into the art and craft of analyzing your data using R. So today we are going to look at the history of R. It's important to know where R came from, its philosophy, its foundations, so that you are better able to appreciate why it is designed the way it is. So welcome, and please subscribe to my channel, and let's get along. Please note that the slides I'm going to present in this video have all been developed using R, using a platform called Quarto. We are going to look at that much later. So even the slides, so instead of using Microsoft PowerPoint, you can always use R and Quarto to design your slides. So let's get into it. And here is the history of R and choosing the right tool from S to R for modern data science, because we are going to see that R originated from a language, a statistical analysis software that was used in the 1970s for analyzing data, that was called S. So we'll see that in more details. So history is important, we all know that, but we are not going to belabor that. So to be able to understand R properly, you need to know where it came from and realize that it did not emerge randomly. What is most important is that R evolved from decades of statistical thinking. Like we said, R was developed by statisticians and not it was not developed by software engineers. So the thinking behind R is a bit different, the philosophy is a bit different. So R is a product of frustration. So statisticians were very frustrated having to use tools designed for other purposes to do their data analysis. So statisticians generally wanted more control over their analysis. When you're analyzing your data, you are able to, have more control. You are going to see how that control comes about. Faster interaction with their data, and less dependence on rigid software. So the other softwares that were there, like we said, data is treated as a secondary operator. In R, data is a first-class citizen. So R was built to think with data, not just pushing buttons. The other softwares we have, Excel, and the others you have to point and click, and that is what R came to undo. So before R, most statistical tools were closed. It means you had no access to the underlying, the source code, what we call the source code, the underlying code. And the software dictated the workflow. You had no control over that. And even today, most of the prominent statistical tools, it is either you have to do what the software is designed to do. You have no control. You cannot define your own way of doing things. And the idea of reproducibility was fragile. This is a very major, issue that is coming up, that research should be reproducible. In other words, when you do your research, somebody else could come in, take the same data that you are working with, analyze it, and be able to reproduce whatever results that you presented. So reproducibility is also a major factor. And thus R came to basically bridge the gap between the analyst, you, the person, the data, the first-class citizen there, and how you go about analyzing this data from its raw form to something that is can be digested by people out there. So the origins of R, like I noted, R originated from a language called S that was developed at Bell Labs in the 1970s, I think specifically in 1976. Of course, most of us were not alive at that time, but it's important to know that there was once a language called S. It was proprietary, so you had to pay some money to really use S. It never really caught on, so it never became a very popular language. But the good thing, it gave the foundation to this awesome language called R that we use today. So the S language, like I said, was developed at Bell Labs. I think Bell Labs eventually was acquired by IBM, and Bell Labs was a very, very prominent lab. It also gave us Unix. Unix is what underlies Linux today. It gave us C, the programming language that is very, very prominent. It underlies a lot of the software that we use in the world today, and the foundations of modern computing. We all know about the GNU project and the others. So, and statistics was also quite important. So the goal of S, the philosophy of S, that ancient language, we could call it ancient because 1970s most of us were not around. The idea was to enable interactive data analysis and prioritize expressiveness over engineering, that you can simply take a software, express what you want to do in like ordinary day-to-day language over the engineering, the software engineering way of looking at analysis. Then reduce the friction between the idea and the result. So you can take your data, you are able to see how you are processing it. You can visualize that idea of the whole process. I came from this data set, now I have these results. So this philosophy still defines R today. So, and this is the defining principle. The analyst should think about the data and not struggle to fight the software. So you are not scratching your head fighting the software. If it is not doing what you want it to do, you can always write your own functions so that R can do what you exactly want it to do. So R is free, open, and community driven. And basically, the birth of R started in the early 1990s when there were two gentlemen who borrowed a lot from the S. Remember, we talked about S. So these two gentlemen from the University of Auckland, they were looking for a software to teach their undergraduate students statistics. This is Rossi Hacker and Robert Gentleman. And I want you to note that the names of these two gentlemen start with R. And that is one of the sources of this name, the beginning of this name R that we are using. Rossi Hacker and Robert Gentleman, they at the University of Auckland. So they wanted a free alternative to S. Remember I said S was proprietary, so you had to pay a license. So they borrowed a lot from it and designed this new language R that was free for all of us to use. So I think I'm not going to overemphasize that. So the name R reflects both its role as the successor of S. I think R comes before S, so they just wanted to play around with it, and the creators themselves, Ross and Robert. So it was first released in 1993. It became a GNU project in 1997, and the first version, the first usable version of R, version 1.0, was released in the year 2000. That is around 26 years ago to this date. So from the beginning, R was free, open source, extensible. Extensible means you can add more packages. Remember the install packages, that you can always install packages. If you use QGIS, remember we can add plugins into QGIS to extend its power. So that's the idea of talking about you can extend it using external packages. So anybody can read the code. You can download the code for R. It's open source. That is why we mean you can improve it and distribute your improvement. So anybody is free to join the movement. I would call it a movement for that matter. So R is maintained by the R core team. The R core team is a team of developers who maintain the language. So there's a lot of hard work. However much we talk about it being free, there's a lot of hard work behind the scene. A lot of people are working very hard. So that's why it's always advisable, if you use R for your data analysis, please remember to cite the language. The citation is available online if you just Google. So it's statistically grounded. Like I said, R treats data as a first-class citizen, and it is conservative about breaking changes. So it's a principle of conservatism that is there in software engineering. So R grew rapidly because of three factors: packages, that is extensions that you can add into R to make it do more than it is originally designed to do. It has a huge community, and there are quite a bit of incentives when you want to join the movement. I would call it a movement because it's really large. The community is really large. So, and these are the reasons why R succeeded. It solved real statistical problems. In other words, somebody who was not a software engineer could come into R, just download it, and start solving statistical problems. And it matched how data analysts actually do their work. Remember, the other programming languages, they were designed for software development. So they really mimicked how software developers think about things. But R is designed to work, to mimic how analysts do work. A good example is, in many other programming languages, counting usually starts from 0. So 0, that is where you start counting. But naturally, in mathematics and in data analysis, we think of counting as starting from 1. You don't count from 0. So that is one of the differences between R and other languages. R is indexed from 1. You start counting from 1. In something like Python, for example, you have to think of counting from 0. The first thing is 0. The second element is 1. The third element is 2, and so on, which can sometimes be very confusing to people who are not software engineers. So that is that. So anybody is welcome to contribute a package. Like I said, a package is think of it as the word itself suggests. It is a package of functions, data, and documentation that other people can use to extend R for their own analysis. So the use cases for R: econometrics, machine learning, GIS, and spatial analysis. So you can use it alongside tools like QGIS, ArcGIS for your spatial analysis. In finance, R is very, very prominent. And text analysis. Remember, nowadays we have the concept of using text as data. So R is also prominent around there. So it is also very well aligned with academia, and it is one of the best tools for analysis in academia. And like I said, it is always important to cite the software when you are doing your analysis. However, it looks free, but there is a lot of work going on under the hood. So please always cite the software. And the good thing with R, like I said, the results are reproducible. And R was originally designed for statistics, but it has moved beyond statistics. So today R is a full data science ecosystem. You can use it from anything from developing apps. You can use Shiny for app development. And it is a full programming language. You can do anything that other programming languages can do. Of course, people who use Python, they will always complain like, the way the code is written is funny, like that. But beyond that, you can write any application you want to write in R. It is a reporting system. Like I said, the slides that I'm presenting here, I have developed them using R, using a system called Qualto. So Qualto is very useful. You can use it to do documents. You can use it for presentations. You can use it for even doing posters and the like. So again, the slides you are watching here are made using R and Qualto. And like I have mentioned before in the previous videos, R is very heavy in visualization. It is very, very good. It is one of the best, especially ggplot that we are going to look at is very, very good in data visualization. So you can always integrate R with other tools. Like you can integrate R with QGIS, for example. You can use SQL from R. You can even use Python from R, C++. So many languages have an integration with R, and we are going to look at them as we move on. So you can collaborate with other people who are working in Python. You do your analysis in R. For example, if you want to do good visualizations, you do your visualization in R. You do something else in Python. You can pull data from SQL, and so on and so on. So I have already mentioned this, no point for belaboring that. So R is no longer just academic. It is a big ecosystem that you can use for many things. So why is R, how does R compare with other tools like Python, SPSS? Why not just use SPSS or Excel? And these are fair questions. One of the problems with the point-and-click software is that they are menu-driven, opaque. In other words, you don't know what happened under the hood. At least Stata is better, you can write some commands. But in Excel, you really know what happens under the hood. And if you are told to reproduce those results, you have to go back to Excel and start clicking all over again from beginning to end. Unless, of course, you know VBA. VBA is there, but it is not a very popular and very accessible language out there. So difficulty in reproducibility is what makes R a better choice compared to the point-and-click software. So point-and-click, like we do in Excel, is quite expensive. There are a lot of hidden things that happen under the hood. You never know what is happening down there. There could be a bug. You cannot audit what happened because you have no way of knowing where did this person start, where did they end. So it discourages learning. So in serious research, clicking is a liability. Pointing and clicking is a liability. So R enforces transparency because you have to write your code. Anybody can follow the code from the beginning to the end, and encourages reproducibility. Somebody else could come, you give them your data, they go through the code step by step, and they can see exactly what you did, which of course is auditable. So we look at R versus Python. So Python is a general purpose language. Like I said, data analysis in Python is an afterthought. And there are some other funny things like counting. You have to count. In Python, you count from 0. You don't count from 1, which is something that really destabilizes people like us who come from mathematical and finance backgrounds. We count from 1. We don't count from 0. So it is strong in software engineering and deployment, but it is not designed for statistics in mind. So in comparison, R has its own advantages, designed by statisticians for statistics from scratch. It is stronger in statistical modeling, visualization, and research workflows. So by design, R is made for data analysis. So that is the chief objective of R is data analysis. So anything else is an afterthought, but data analysis is central. Most other competing languages like Python, data analysis is quite secondary for that. So in many cases, you realize that you are using R and Python together. In a number of cases, you realize you use R for your data analysis, Python for your deployment, and you choose tools. And this is what I encourage people all the time: choose the right tool for the right job. So, you can't use a sledgehammer to kill a fly. So if you just want to do good visualizations, you can use R. If you want to do deployment, you can use Python. In some very simple cases, even Excel is good enough for your analysis. So always choose the tool that solves your problem. So when do you use R? When statistical rigor matters, when visualization quality matters, because visualization is very good in R, reproducibility is critical, and your work in analytics heavy fields. And what we have here is a diagram that shows the evolution of R in a nutshell, starting from Bell Labs to Rossi Hacker and his friend at the University of Auckland, the creation of R in the 1990s, and so on. So this is something to help you think about how R has evolved. So starting from S, I'm not sure whether S exists today, but what is important, any code written in S, it can run in R without really doing a lot of alteration. Clan here is a repository where packages that people publish are stored. Like we said, packages are extensions. So when you create your package, in many cases you put it in CRAN. Of course, you can always put it on GitHub. You can host it on GitHub and other platforms. But CRAN is the most central. So the final thought, R is not just a language. It is a philosophy of statistical analysis with a culture of openness and reproducibility, and a tool built for thinking with data. So in the next section, we are going to install R and start writing some code. So it is important to know how to install R properly. And R is cross-platform, so you can use it whether using Mac, whether using Windows or Linux like I do. I use Ubuntu in my case. So don't worry, but my computer is learning Mac. We are going to be able to do all that quite well. So thank you very much, and please subscribe, follow for the next section. In the next section now we are going to do the installation and start learning some simple commands. So thank you and welcome